Namaste, I am Mrs. Arumugalakshmi. Today we are going to discuss the topic Prism in Lesson 6 Ray Optics in Volume 2 of Class 12 Physics. In this video we are going to discuss about prism, how refraction is taking place in prism, how to calculate the angle of deviation produced by a prism and the problems related to angle of deviation, angle of minimum deviation, refractive index of the material of the prism and problems related to refractive index, dispersion of white light through prism and finally how to calculate the expression for dispersive power. These are the topics which are going to be discussed in this video. First, let us see what is prism. A prism is a triangular block of transparent glass. It is bounded by three plane surfaces. If you see the diagram nearby, you can see the three faces. The face which is rough is called as the base of the prism. Follow my pointer, you can see the base. The other two faces which are polished and they are called as the refracting faces of the prism. The angle between the two refracting faces is called as the angle of prism. This is the angle of prism and it is also called as refracting angle or the apex angle. Now we are going to discuss how to find the angle of deviation in the prism. For this we are considering a prism ABC where PQ is the incident ray. You know when the light ray is moving from one medium to other medium, it undergoes refraction. Here the light ray is moving from air to glass medium. So it undergoes refraction and the path of the light ray is QR after refraction. The dotted line represents the normal and here I1 which is the angle between the incident ray and the normal, it is called as the angle of incidence at the first phase. Similarly R1 which is the angle between the refracted ray and the normal. This is the angle of refraction at the first phase and the path of the light inside the prism is QR. Now the same light ray you can pass through the next surface AC. So when it is passing through AC, I2 is the angle of incidence at the second phase, R2 is the angle of refraction at the second phase, where RS is the emergent ray from the second phase and I2 is the angle of emergence. We know the definition of angle of deviation as the angle between the incident ray and the emergent ray. So the incident ray is PQ, the emergent ray is RS. To find the angle between them, we are extending these two rays and they meet at a point M and here you can see the angle of deviation formed which is D. The red dotted line represents the incident ray and the emergent ray which are extended. Now the angle of deviation D1 at the surface AB is RQM which is equal to D1 which is equal to I1 minus R1. Already under the topic refraction we have seen how to find the angle of deviation. Using that formula, we find D1 is equal to I1 minus R1. Similarly, the angle of deviation at the next surface AC is angle QRM which is equal to D2 which is equal to I2 minus R2. Now the total angle of deviation, we have to add these two. So when you add these two, we get D is equal to D1 plus D2. Now substitute the value of D1 and D2 what we have got in the equation 1. When you substitute, you get D is equal to I1 minus R1 plus I2 minus R2. Now a small rearrangement. We are combining the I on one side and the R on the other side. So how will we combine? D is equal to I1 plus I2 minus sign we are taking it outside. So inside the bracket it becomes R1 plus R2. This equation you keep it as 4. The first equation is D is equal to D1 plus D2. Next, see the quadrilateral AQNR. Follow my pointer, you can see the quadrilateral AQNR. In this quadrilateral, the two angles, that is the vertices Q and R, are right angles because it is the angle formed in the normal. So these two angles Q and R are right angles, and we know the sum of the other two angles should be 180. That is the angle formed at A and angle formed at this N. The sum of these two angles should be 180. So angle A plus QNR is equal to 180. This equation have it as 2. Now take the triangle QNR. QNR. Follow my pointer. You can see the triangle QNR. You know the angle formed in a triangle is also 180. So this N angle, N means normal. So this angle will be 90. So the remaining two angles, that is R1 plus R2 plus QNR, should be equal to 180. So this equation, keep it as 3. Now compare equations 2 and 3. Angle 180 is in common, angle QNR is in common. So the third one, that is A, should be equal to R1 plus R2. So how we are writing the equation? We are writing it as R1 plus R2 is equal to A. Now we are going to substitute this equation in 4. Fourth equation for your reference is D is equal to I1 plus I2 minus R1 plus R2. For this R1 plus R2, I am going to substitute it as A. So we are back in our slide. So R1 plus R2 is equal to A. This we are going to substitute in equation 4. So when you are substituting, D is equal to I1 plus I2 minus A. So this is the expression for angle of deviation. D is equal to I1 plus I2 minus A, where A is the angle of prism. So the angle of deviation for the monochromatic light depends upon the angle of incidence, the angle of prism, and the refractive index of the material of the prism. Next, we are going to see some problems related to the angle of deviation. First problem is light falls at a normal incidence on the first phase and emerges grazing the second phase for an equilateral prism. What is the angle of deviation produced and what is the refractive index of the material of the prism? The prism is given as an equilateral triangle. So the angle should be, the angle A, that is the angle of the prism, should be 60 degree, and I1 is given as 0 degree and I2 is equal to 90 degree, because it is given that the light ray emerges grazing the second phase. So when it grazes the second phase, that is, it is on the second phase. If you see the diagram, you can see this refracted light ray grazes the second surface. So the angle between them will be 90 degree. So you know the equation of angle of deviation. D is equal to I1 plus I2 minus A. Substituting I1, I2 value, A value, we get D is equal to 0 plus 90 minus 60, which is equal to 30 degree. Next, we have to find the refractive index. We know that when the light is falling on the second surface, it should be, you know, the principle of prism is total internal reflection. So the angle of incidence should be greater than the critical angle. Then only the light will undergo the total internal reflection. So we have to find what is IC. IC is the critical angle. See the diagram. Here the total angle is 90 degree. Angle of deviation, now we have found it as 30. So IC will be, the total angle is 90. The angle of deviation is 30. So the value of IC should be 90 minus 30, which is 60. And we know the expression for critical angle. Sin IC is equal to 1 by n, where n is the refractive index of the material of the prism. So here we need to find the n value. So we are reversing this formula such that n is equal to 1 by sine IC, which is equal to n is equal to 1 by sine IC value we are substituting here, which is 60 degree. Sine 60 is root 3 by 2. So 1 divided by root 3 by 2. The 2 goes to the numerator. It becomes 2 by root 3. Root 3 value we know that it is 1.732. So 2 divided by 1.732 is 1.15. The refractive index of the material of the prism value is 1.15. Next, we will see what is angle of minimum deviation. For this, we are drawing a graph in which we take angle of incidence in x-axis and angle of deviation in y-axis. And now we are increasing the angle of incidence. See the graph. When the angle of incidence is increasing, the angle of deviation is decreasing. There is a minimum value of d, after which you increase the angle of incidence. Without decreasing, the angle of deviation starts increasing. See the red color curve? You can find what I say. So, there is a minimum angle for deviation, after which the angle of deviation increases with the increase in angle of incidence. That angle is called as angle of minimum deviation. Hence, the definition of minimum deviation is the minimum value of angle of deviation is called as the angle of minimum deviation. At minimum deviation position, there are two possibilities. One is angle of incidence should be equal to angle of emergence. If you see the diagram which is given nearby, both the angle I, if you see the red color line is the incident line and the next face, the red color line is the emergent line. Both the angles are marked as I because angle of incidence is equal to angle of emergence. So, both the values are marked as I. The second one is the angle of refraction at the phase 1 should be equal to the angle of refraction at the phase 2. That is R1 should be equal to R2. If you see the diagram, both R1 and R2 are same and they are represented by small r. This is the condition for minimum deviation. And the third one is the refracted ray inside the prism is parallel to the base of the prism. See the line, red color line inside the prism. Isn't it parallel to the base of the prism? So these are the three conditions which happens during angle of minimum deviation. Now, we are going to find the expression for refractive index of the material of the prism. So, at minimum deviation, we know the condition that I1 is equal to I2 is equal to I and R1 is equal to R2 is equal to R. Now, we know the expression for angle of deviation as D is equal to I1 plus I2 minus A. From this, we are substituting the minimum deviation condition, that is I1 is equal to I2 is equal to I. So I1 plus I2 becomes 2I. So D is equal to 2I minus A. From this we are finding an expression for I. So take the D this side. So the equation becomes I is equal to A plus D divided by 2. Now, the second equation, you know that R1 plus R2 is equal to A. So, in this equation, again substitute the minimum deviation condition, which is R1 is equal to R2 is equal to R. So, the equation becomes 2R is equal to A. From this equation, find R. So, R will be equal to A by 2. I will be equal to A plus D by 2. Now these two values of I and R, we are going to substitute in Snell's law. Snell's law, according to Snell's law, you know that N is equal to, N is the refractive index which is equal to sin I by sin R. Substitute I value and R value, we get N is equal to sin A plus D by 2 divided by sin A by 2. This is the expression for refractive index of the material of the prism. If you know the A value and D value, easily we can find the refractive index of the material of the prism. Now here is a problem for finding the refractive index. the angle of minimum deviation for an equilateral prism is 37 degree. So D is given as 37 degree. It is the equilateral prism. So angle is equal to A is equal to 60 degree. We have to find the refractive index of the material of the prism. You know the formula, refractive index N is equal to sin A plus D by 2 divided by sin A by 2. Substituting the value of A and D, we get N is equal to sin 60 plus 37 divided by 2, the whole divided by sin 60 divided by 2. So the equation becomes sin 48.5 degrees divided by sin 30 degree. Substituting the value of sin, we get 0.75 divided by 0.5, which is equal to 1.5. The refractive index of the material of the prism is 1.5. Next, we are going to see the phenomenon of dispersion of white light through prism. When you take white light and pass it to a prism, an important effect called dispersion takes place. Dispersion is nothing but splitting of white light into its constituent colors. We get a band of colors when the light ray is passed through the prism, and this band of colors is called as spectrum. When a narrow beam of parallel rays of white light is incident on a prism and the refracted beam is received on a white screen, you get a band of colors. A band of colors is obtained in the order recollected by the word Vibgyor, that is violet, indigo, blue, green, yellow, orange and red. The violet is the most deviated color and the red is the least deviated color. You can see how dispersion is taking place in the diagram below. If you see violet, it is most deviated from the straight line, but red is the least deviated one. How this refraction takes place? When white light enters the medium, the red color travels with the highest speed and violet color travels with the least speed. Hence, the wavelength of the colors in medium are no longer the same as they are in the vacuum. Actually, the dispersion takes place in a medium because of the difference in speed for different colors in a medium. Since they travel with different speed, the dispersion takes place. That is, the refraction, the angle in which they are deviated from the incident ray is different for the different colors. In other words, you can say this as the refractive index of the material of the prism is different for different colors. For violet color, the refractive index is the highest, and for red color, the refractive index is the least. Now let us find an expression for dispersive power. How much is the dispersive power for a prism? For this, we are going to find an expression. So we are considering a beam of white light which is passed through a prism. It gets dispersed into its constituent colors as shown in the figure above. If the angle of prism is small, very small, of the order 10 degrees, the prism is said to be a small angle prism. When rays of light pass through such prism, the angle of deviation, that is the angle of minimum deviation, will also become very small. Hence, we represent A as the angle of small angled prism, and for minimum deviation, we are not using the symbol D. We are using the symbol del. This, just follow my pointer. This is the symbol del, which is used for the angle of minimum deviation. Then the expression for refractive index becomes, you know the formula for refractive index is N is equal to sin A plus D divided by 2, the whole divided by sin A by 2. Instead of D, we are using the symbol as del. So, when angle of prism and angle of minimum deviation are very small, we know that sin theta, when theta is very small, sin theta will be equal to theta. Similarly here, when A and del are very small, sin A plus del divided by 2 becomes A plus del divided by 2. Similarly, sin A by 2 becomes A by 2. So, the 2 which is in the denominator gets cancelled and you will have the expression for refractive index as A plus del divided by A. You can cancel A in the numerator and a in the denominator for each term. So we will get a plus del by a. So n is equal to 1 plus del by a. The one you take it to the other side, we have del by a is equal to n minus 1. If you find an expression for del, del is equal to n minus 1 into a. This is the expression for del. When white light enters the prism, the deviation is different for different colors. Here the expression del represents the deviation. Thus the refractive index is also different for different colors. So we are representing del V and del R are the angle of minimum deviation for violet and red color respectively. And NV and NR are the refractive indices for violet and red color. So for violet color, we are writing the expression for dispersion as del suffix V is equal to NV minus 1 into A. Similarly, we are writing for red color as del R is equal to NR minus 1 into A. As the angle of minimum deviation for violet color, del V is greater than del R. So we are finding the subtraction of del R from del V. So del V minus del R is equal to, you have to subtract these two expressions. So before subtracting, you will take A inside the, follow my pointer, you will understand. Take A inside the bracket. So NV into A minus A. Similarly here for red color, you take A inside the bracket. You will have NRA minus A. Now you have to subtract these two equations. When you subtract these two equations, the term A will get cancelled and you will get del V minus del R is equal to NV minus NR into A. So the angular separation between the two extreme colors in the spectrum is del V minus del R. If you take del is the angle of minimum deviation for any mean color and n is the corresponding refractive index, then we can write this equation as del is equal to n minus 1 into A, where omega is the dispersive power and it is defined as the ratio of angular dispersion for the extreme colors to the deviation for any middle color. And dispersive power is the ability of the material of the prism to produce dispersion. Hence, the expression for dispersive power omega is angular dispersion divided by middle deviation. Angular dispersion is difference between del V minus del R. Middle deviation, we are taking it as del in general. So now we can substitute for del V and del R and del. We get the equation as NV minus NR divided by N minus 1. The dispersive power, it is a dimensionless quantity and the unit also is dimensionless. The dispersive power is always positive and the dispersive power of a prism depends only on the nature of the material of the prism and it is independent of the angle of prism. How did we get this statement? If you see the expression for dispersive power, it depends upon the n value only. N means the refractive index of the medium only. It doesn't depend upon the A value, angle of prism or angle of deviation. Thus we have concluded like this. So the expression for omega is the dispersive power, which is NV minus NR the whole divided by N minus 1.